Hello everyone, myself Hans. Today we are going to solve the problem of UPSC Maths Optional Paper 1 question from topic differentiation under the sign of integration. Here in the question, show that if a is greater than equal to 1 and integral limit is 0 to pi by 2 log of 1 plus of a sine square x upon sine square x dx, and we have to prove pi bracket under root of 1 plus a minus of 1 if a is greater than 1. Let's solve the problem. Given integral is, that is taking left hand side, it is I is equal to, this is 0 to pi by 2 and log of 1 plus of a sine square x upon sine square x dx. We taking LHS and we have to prove RHS here, and further here is the parameter is a, and let this is equation 1. Differentiating equation 1 with respect to parameter a, then this is given by di upon dA is equal to, here is integral limit is 0 to pi by 2 and we can differentiating log of 1 plus of a sine square x, and with respect to parameter a, this is given by 1 upon of sine square x is already present in the denominator, and here 1 plus of a sine square x, and again 1 plus of a sine square x differentiating with respect to parameter a gives sine square x, and from here this is dx, sine square x to sine square x is cancelled out, and the remaining is integral limit is 0 to pi by 2 and this is given by dx upon 1 plus of a sine square x, and we know that cos square x plus of sine square x is equal to 1 from trigonometry, and this is identity, that is cos square x plus sine square x is equal to 1. So we have to use here in place of 1, that is cos square x plus sin square x. This is di upon dA, and integral limit is 0 to pi by 2 and this is dx, and here is in place of 1 we have to write cos square x plus of sin square x, and here is already present, that is a sine square x. Further we have to solve. Integral limit is 0 to pi by 2 and this is dx upon, from here we have to take common sine square x and a sine square x we have to take common. First we have to write cos square x and plus of taking sine square x is common, and the remaining is 1 plus of a, and further we have to dividing numerator and denominator once again, denominator of right hand side by cos square x, then di upon dA is equal to, integral limit is 0 to pi by 2, on dividing dx upon cos square x, this is given by sec square x dx upon, and here we have to divide cos square x with cos square x, this is 1, and from here we have to divide sin square x plus cos square x, this is given by tan square x 1 plus of a, and further we have to take common from denominator, that is 1 plus of a, 1 plus of a, once again, this is given by integral limit is 0 to pi by 2, and this is sec square x dx upon, and from here we have to take common 1 plus of a common. This is given by here 1 upon of 1 plus of a and plus of tan square x, and further we have to take outside 1 plus of a. This is given by 1 upon 1 plus of a, and integral limit is 0 to pi by 2, and this is given by sec square x dx upon 1 upon of 1 plus of a and plus of tan square x, and further we have to let here, that is tan x is equal to t, then differentiating tan x, that is sec square x dx is equal to dt, this is dx, and we have to change the limit also when putting x is equal to 0. When x is equal to 0, then t is equal to also 0, and when we have to put x is equal to pi by 2, then t is equal to infinite. Further we have to put the limit also, that is di upon dA is equal to, here is the limit is changed once again, 1 upon of 1 plus of a, and the integral limit is changed, that is 0 to infinity, and here is in place of sec square x dx we have to put dt. Here we have to let tan x barabar t, that is sec square x dx, sec square dx in place of we have to put dt upon, here is 1 upon of 1 plus of a, and in place of tan square x we have to put t square, and we know the formula. This is given by integration of dx upon a square plus of x square is given by 1 by a tan inverse of x by a. So we have to use here. Further we can also write, that is 1 upon of 1 plus of a, and integral limit is 0 to infinity, and this is dt upon, we can also write 1 upon of 1 plus of a under root का whole square plus of t square. On squaring we get 1 upon 1 plus of a, and further we have to use the formula dx upon a square plus of x square is equal to 1 by a of tan inverse x, that is 1 by a. 1 by a, here is 1 by a is 1 upon 1 plus a, so from here 1 upon 1 plus of a, and this is 1 by a is 1 upon under root of 1 plus of a, so from here this is root 1 plus of a, and tan inverse of x by a. Here x is t and x upon a, that is 1 upon 1 plus of a, so we have to write here, that is 1 plus of a, and further we have to put the limit. This is 0 to infinity, and from here, that is 1 plus of a and 1 plus of under root 1 plus of root a cancel out, and the remaining is here under root of 1 plus of a, that is di upon dA is equal to 1 upon 1 under root of 1 plus of a, and here we have to put in place of t. When we have to put t in place of infinity, we all get infinity, and the value of tan and t is infinity. The tan and t and tan inverse we have to remove from here, and we get pi by 2. And from here this is pi by 2 and 1 upon of under root of 1 plus of a, and this is also written as di is equal to pi by 2 and 1 upon of under root of 1 plus of a dA, and integrating both the sides. This is given on integration of dy. This is I, and here is pi by 2 is taking constant, and integration of dA upon under root of 1 plus of a. We can also write in the form of, once again, we can also write that is 1 plus of a to the power 1 by 2, and take into numerator, that is minus 1 by 2, and this is dA on integration. This is given by I is equal to pi by 2, and integration of 1 plus of a, this is given by 1 plus of a and minus 1 by 2 plus 1 upon minus 1 by 2 plus of 1, and plus of c taking constant, and further we have to solve. That is I is equal to pi by 2, and here is 1 plus of a and minus 1 by 2 and plus 1 by 2. This is given by 1 by 2, and upon here is minus 1 by 2 plus of 1 by 2. This is 1 by 2, and further we have to solve, taking into denominator of 1 plus of, we can already write here, that is pi by 2, and this is given by, here 1 by 2 is taken into denominator, that is 2 under root of 1 plus of a, and 2 to 2 is cancelled out, and here is c is already present, and this is given by I is equal to pi into 1 plus of a plus of c, and we have to find the value of I, putting a is equal to 0 in equation 1, we get I is equal to 0. When we have to put here that in place of a 0, this part is 0 and log 1 is 0, we get I is equal to 0, and from here, that is I is equal to pi and under root of 1 plus of 0 plus of c, and from here I is also 0, so I have to put here 0, and we have to find the value of c, that is c is given by minus of pi, and we have to put here the value of pi here, that is I is equal to pi under root of 1 plus of a and minus of pi, and from here pi is taking common, that is pi is taking common, that is under root of 1 plus of a minus of 1. This is the required solution of the given problem, which I have to prove. This is pi under root of 1 plus of a minus 1. This is equal to RHS. Thank you class, and thank you for watching.